Hi, I'm Graham Francis,
I'm Matt Morris.
I'm Alex Wickman.
and we're here to talk to you today about the plastics add-in for Solidworks. Plastics add-in for Solidworks can be used on any part. It doesn't have to be made any specific way. You can just import it into the add-in and analyze it as if you were going to use it as a plastic injection mold part. So the most important part is going to be your mesh for your study. The mesh for your study determines how accurately your study runs and how long it will take. So if you make a really small element size, it's actually going to take a really long time. It could even crash your computer, but you'll get far more accurate results. So the key is to try and find a happy medium. Most people change their mesh in 3 separate increments that actually validates your results, showing that they converge on a certain value. But you want to keep in mind to not go too small, otherwise obviously it won't run. So I'll show you 2 different options here. The first one is going to be a mesh element size of 6 millimeters. This is a pretty big part. So if we run with 6 millimeters, you can see that it gives pretty big element size here. And then if we do it again with 2, it actually does a really fine one. The issue with too fine is it might take you a while to run. You're better off starting with obviously a bigger mesh. So we're going to move forward with this. I'm not actually going to run the mesh today for the sake of time because the studies do take a while to run. It tells you if the mesh is waterproof, basically meaning if there's any gaps or any nodes that haven't connected. And then if for some reason there were, it gives you a bunch of tools to help you merge those nodes and speed up time. So then we'll run through tetrahedral and hexahedral. It gives you a different shape of mesh size. Tetrahedral is pretty standard. It runs a lot faster, so that's what we went with today. It lets you do a different shape of mesh in different areas, and ultimately it'll have me create the mesh. I'm not going to do that for the sake of time today. We already have the mesh created. So we'll exit out of that, and then Matt will talk about the polymers we can use.
So Solidworks gives us a really big polymer database. You can see that you can sort by the family or by the company. You see I have like 3M, you scroll down. We have Chevron. We also have DuPont farther down here. But for our part, we just chose an ABS plastic, a generic material that you see there. Solidworks gives us a whole bunch of other properties for all the materials that you use. So if you're interested in looking at any of those, it provides a really large material database for that. Likewise, it also provides a large database of materials for your mold, what metal you're going to use out of that. We're just going to use an aluminum alloy, but this is great for helping you choose if you're going to do a long-term part run or just a prototype. If you're going to do long-term runs, you need to be using a tooling steel, and that's all going to affect the rate at which your part cools, and how fast or how much pressure you're going to need to put into that. So next we're going to go take a look at fill settings. These are all just SolidWorks auto fill-ins. You have your melt temperature, a mold temperature, and an injection pressure. All 3 of these are going to affect how fast your mold fills, how long your part takes to cool, and how fast the mold fills, and if there's any air pressure inside, or any air bubbles inside of it. To get rid of air bubbles, you're going to do a vent analysis. We have an external ambient air temperature of 25 degrees C and just an ambient air temperature of 0.1 megapascals. So we're going to go ahead and accept those. And then you're going to choose an injection location. These have already been chosen on this part. They're right here. I'm not going to mess with them. SolidWorks did not choose these. These were user defined, but you go ahead and you find a node. And then you're going to have to click add location. So we're going to accept those 2. And then your other 2 locations are your vents. In here, you can, it won't show you until you run the analysis, but we implemented our vents at each end of the part, here and here. So I'm going to cancel these as we've already selected them. And then we're going to run the analysis, and I'm going to let Alex talk to you about the results.
Okay, in the results sections, we can see several options in terms of plots, summaries. Most of the information that is important to us will be under the flow results. Now, within here, there are a number of features. Using the plastics added in SolidWorks allows us to simulate 3D model parts as if they were injected molded, and also not only quantify but qualify that part under our specific injection locations and vents, whether or not this is going to be a successful process. And then from the information we receive, how are we going to adjust the geometry of that part, considering thickness, but also material, and our method for molding and injection to get the best part. Initially here, we can view the animation, which will show us on the time scale the filling of the part. This naturally is looped. We'll pause that so no one loses focus. Looking at the fill time, what we can see on this scale on the right is our total fill time and the scale from the beginning of injection to the end. There's a lot of information here you can read in the available results column. Some important details to consider. We'll mention two, one of which is the pressure at the end of fill. On the scale on the left, we can see our maximum pressure. What this tells us is the size of injection machine that will be required for manufacture of this part. This is, of course, a very important detail for engineers. Another feature available is the cooling time. Once again, we can see the time scale on the left. A useful tool is using the clip-in options to dissect the part, therefore providing a cross-section inspection of what's going on over that time scale and what the temperature of the material is. And in conclusion of all of this information and what it tells us for our mold and how we can change our part, SolidWorks provides a useful option under the Advisor tab. You here on the right of the screen, we see that SolidWorks tells us that our part has been successfully filled. It also reports some of the information that we have seen on our left, and though this part is successful, if the part was unsuccessful, in this box on the top right of the screen, we would find recommendations, how we would change our material, fill pressure, packing percentage to achieve a better injection molded part. Now if I click back, a couple of things I skipped over, back under the fill time. Not only does the simulation provide us with these gradients and quantifiable metrics, but we can also identify weld lines and air traps, defects within the injection mold part that we'd like to know where they're going to exist and occur. If we unclick weld lines, we'll back see our part, remove the clipping, and here the purple dots reveal air traps in the part. This part was relatively successful in the molding process, though more complex geometries could imagine seeing a lot of defects that we would then manipulate the injection process to have a better part. And that's a rundown of the SolidWorks Plastics add-in. This is an extremely useful tool for simulating our 3D models and finding what constraints and parameters will be important in having a successful manufacturing process.
If you have any other questions, feel free to email Bob Charlton.